All right, this is going to be our third example. We're looking to find absolute max, absolute min on this open interval. Notice open, we do not include -5, do not include -1. All right, so let's look at this. This is a rational function. Let's get a sense of what we're looking at. Rational function. And if I take this denominator, set it equal to 0, I can find the vertical asymptote here. X is equal to -1. Get an idea of what I'm looking at. Here's my x-axis, here's my y-axis. Now here is -5 somewhere. Here is -1. Now if I have a vertical asymptote at -1, or x is equal to -1, we have this so far. Now my graph's either going to come like this or like that. It's going to approach infinity or negative infinity. Let's see. How can I determine whether my graph goes to infinity or negative infinity as I approach -1? Think about it. If you approach -1 from the left, it's just a limit problem. Let's see what happens. Limit as x approaches -1 from the left of f of x. Same thing as limit as x approaches -1 from the left of x squared plus 4 over x plus 1, because that is what f of x is. All right, so I'm going to let y'all go ahead and take that limit, just so I don't bore y'all with this video, would make it too long. I get this thing is negative infinity. So that means that your function is going to approach negative infinity as you approach -1 from the left-hand side. So automatically, if it goes off to negative infinity, I have no absolute min. So I can go ahead and put that, no absolute min. Let's see what happens on the other side as I approach -5. And which way am I approaching -5 from? The right-hand side. So let's take the limit as x approaches -5 from the right of f of x, which is the limit as x approaches -5 from the right of x squared plus 4 over x plus 1. Now, this will be a good exercise to pause the video and go through and work this limit yourself. And then whenever you hit play, you can see if you got the same thing I got. Got -29/4. Okay, so this thing's not going off to say infinity or negative infinity or anything like that, okay? So I should have an absolute max on this interval. We already ruled out absolute min. So let's see, where could that absolute max occur? Well, at a critical point. Let's find my critical points. All right, so let's find f prime of x. Well, according to the rules here, I've got to use the quotient rule. All right, I'm back. I cannot go ahead and write out the whole derivative with all the steps here because I have very limited board space. I'm still trying to figure out this recording stuff. All right, so let's take this derivative, find out where it's equal to 0. X squared plus 2x minus 4, where that's equal to 0. Well, again, I'm cutting out of board space here. But whenever I solve this, I can use the quadratic formula. I come up with x is equal to -1 plus or minus the square root of 5. So that's two cases. That's x is equal to -1 plus the square root of 5, and that's x is equal to -1 minus the square root of 5. All right. Let's also find where my derivative is undefined. Take my denominator, x plus 1 squared, find out where it's equal to 0. So x plus 1 is equal to 0, x is equal to -1. Now this value of -1, I can throw out because -1 is not included in this interval because of the parenthesis. We go up to -1, but we do not include it. Let's see if there's anything over here I could throw out. Let's see. Square root of 5, a little bit larger than the square root of 4. Square root of 4 is 2, a little bit larger than 2 is 2 point something. -1 plus 2 point something. Does that put me in this interval? No, it does not. Throw that out. How about -1 minus 2 point something? -1 minus 2 point something is what? -3 point something? And you could use a calculator, put these in and see what you get if you don't like doing it my way. All right, so this -3 point something is in this interval. So that's my only critical point in that interval, okay? Now, technically what I need to do is I need to check this, okay? I need to say, okay, -1 minus square root of 5, and I need to check the signs on each side of this and so forth, okay? But I'm gonna leave that up to y'all. Well, let me say this. Whenever I put -1 minus square root of 5 here, you might wanna find a decimal equivalent to this in your calculator, and then that'll give you clear values of what to check on the left, what to check on the right. And this is going to be where my absolute maximum occurs. So I'm going to have absolute max. I'm going to fill that in a little bit. Oh, I'm off the screen. Hold on. Go back over here. Absolute max of a blank occurs at x is equal to -1 minus square root of 5. Now we're going to fill in that blank. We're going to find that actual max. How do I go about finding that max? Well, I evaluate my original function at -1 minus square root of 5. So take f of -1 minus square root of 5 is equal to -1 minus square root of 5 squared plus 4 over -1 minus square root of 5 plus 1. All right, so that's 1. If I square this up, remember you don't want to square each term. You want to square the correct way you square a binomial. Plus 2 square roots of 5 plus 5 plus 4 over negative square root of 5. So that gives me, what, 10 plus 2 square roots of 5 over negative square root of 5. And that gives me -10 over square root of 5 minus 2. And that is my absolute max. -10 over square root of 5 minus 2. Absolute max occurs there. And I guess I need to know no absolute min.